Well, we're getting closer to our spring severe weather season here in North Alabama and southern Middle Tennessee. I want to show you this graphic here just to show you how important it is to stay weather alert this time of year. This is from the National Weather Service office going back to 1950 to just 2021. So we haven't counted the last couple of years here, but you can see a distinct increase in the number of tornadoes as we get from February into March. And with the climate changing, with it getting warmer, not only are we having earlier pollen season as we've been talking about, but the severe weather season actually has moved up as well. But notice April, that's where we peak with the number of tornadoes since 1950, 555 tornadoes in the state of Alabama. And you can see here in February, we have to watch that as well. And this goes all the way sometimes to the end of May and early June, but definitely a decrease in the month of June, July, and August. And this is because the jet stream, the wind shear is not near as pronounced, and then it comes back in November. So let's talk about how these tornadoes develop, the setup in the first place here. Typically, when we talk about significant tornadoes this time of year, we get these individual type thunderstorms. You get this updraft that goes in. There's a lot of wind shear in place, and typically the wind in the upper levels is from the west-southwest, and that's why the storms, typically the stronger ones, the severe ones, move off to the northeast. So we get a big mess going on here. There's a lot of updraft and downdraft mixing going on, and you get what's called a rear flank downdraft that will often start the precursor to developing a tornado. There's a lot more than just cold air meeting warm air in here. Here's basically the setup as we talk about wind shear, and that's very important. Wind shear and instability. When we get those combined and we get tornado watch, which means conditions are favorable for the possibility that if we do get storms, we could see tornadoes. That's when you really need to keep in mind the wind setup. The change in direction with height, and also as you change in direction in speed as well. So you get speed shear and directional shear. The rotation starts to develop within the thunderstorm, and then you get this rotating column of air. It's rotating horizontally. But as you saw in that last picture, you've got these updrafts going on in here as well. And what that does is that begins to stretch this tube, and it causes it to go vertical. And that's when we get the tornado to develop within the strong lift. And oftentimes, these are obscured. These are what we call HP supercells, which means high precipitation here in North Alabama and southern Middle Tennessee. And that means you can't always see the tornado. And often they're covered by the big pine trees out there. So we use Doppler radar. And one of the ways to see Doppler radar, the tornadoes, is in the velocity pattern. We're going to go over that. The supercell structures, those are the ones that are the most dangerous. Those are those EF3, EF4, and EF5 type tornadoes. Then your bookend vortex, the spin up tornadoes, and then we'll get into debris signature as well. So as far as the velocity pattern goes, when you're looking at the actual Doppler radar, we talk about velocity. We talk about rotation. You may hear us reference broad rotation. That's kind of the first indication we have any rotation at all, and typically there's not much going on. But then you get weak rotation, and then it becomes strong rotation. You can see the greens and the reds here coming together. That is a tornado signature on radar as far as the velocity goes. So when you break down the supercell structure, you get a storm that looks like this with a big hook echo down here on the southern side. That's where the tornado is going to be. You get a really strong inflow into that tornado as well, so you can get damaging winds even if you're not directly hit by the tornado. Now, other parts of these supercells, and that's again, when we talk supercells, that's when a lot of people's ears perk up, and that's why it's so important to stay weather alert on those types of days. You'll get large hail. Typically, our supercell storms will produce golf ball to, at times, baseball size hail on those bigger days. And also on the leading edge, you get a really strong gust front. And typically with the supercell, the larger the hail, the greener the sky will be indicated out there. So you actually be able to see it. We call it the mean green. Now the bookend vortex, we get those in the cooler weather seasons, but we can also get them when we get these big squall lines that come in typically in June and July as well. You'll get a tornado it looks like a bookend here. It's going to be in this comma head on the north side, and then you get straight line wind here in this bowing echo segment. Again, so that's what that bookend vortex type tornado looks like on radar. And then we get spin up tornadoes. These are typically your EF0, EF1 type tornadoes, and what those will do, they develop when we have a lot of wind shear and we don't necessarily have a lot of instability. So what will happen is you get these line breaks here between storms, and you'll also see areas with notches in them too on the leading edge. These are very brief. They last maybe 5 minutes at most, and sometimes they're only on the ground for about 2 or 3 miles. So again, the notches there, and then the line breaks within the line. As far as a tornado debris signature on radar, let's talk briefly about what that looks like. What you'll see, what you're basically looking for, it's called the correlation coefficient. This is the dual pole next-rad Doppler radar, and you'll see an area of blue within these areas of red, and you kind of see the debris ball here. That's an indication that the storm has a tornado on the ground and it is lofting the debris in the air.